Hello everyone, and welcome to this how-to video on the Cultivate Geospatial YouTube channel. For those that may not know what Cultivate Geospatial is, we are a leading GIS and asset management consulting company with clients that include local governments, state and federal agencies, educational institutions, and other private sector companies out there. So if you need any help with GIS or asset management related things, feel free to look us up. We'd be happy to help you out. Now, me personally, I am Trip Corbin. I'm a senior GIS professional consultant and instructor here at Cultivate Geospatial. I have over 28 years of geospatial experience working with a large amount of different types of applications. Obviously, ArcGIS, AutoCAD, Map, MicroStation, a bunch of Trimble things, and so on. I hold multiple certifications in GIS and IT, including being a GIS certified professional. I hold several ArcGIS certifications, some Microsoft certifications, some CompTIA certifications, and so on. So, been around, done a whole lot. I've also written 3 books on ArcGIS Pro, as you can see here in my picture. That's my latest book on ArcGIS Pro 3.x. So in this video, I really want to show you how you can create scenes in ArcGIS Pro so that this is a new way you can use to highlight and visualize your data that you've not been able to accomplish in the older ArcMap application that ArcGIS Pro is replacing. When ArcGIS Pro first came out in 2015, if I remember correctly, it's hard to believe it's been out that long. I am shocked every time I say that, right? But yes, it's been out since 2015, and one of the core functions it brought to the table was this ability to natively visualize your data in 3D. This is not something that you could do in the old ArcMap without having the 3D Analyst extension. But even then, that required you to go into a different application, being either ArcScene or ArcGlobe, in order to build these 3D visualizations of your information. So with ArcPro, this is now a core component of this application. And we do that 3D visualization through a scene. So a scene is, in essence, a 3D map. So you don't have to say a 3D scene, a scene by default is 3D. You'll still probably hear me say 3D scene because I am so used to doing that when teaching classes on this, just to make sure people understand that that's what I'm talking about. But you don't really need to do that anymore. The scene is by default 3D. And like I said, this is part of the core functionality of ArcGIS Pro. It doesn't matter what license level you have, whether it's basic, standard, or advanced. You can create these 3D visualizations inside of our ArcGIS Pro. Now, a scene is going to include a combination, in most cases, of 2D and 3D data. You're going to have 2D data that often sets kind of the context of the scene. It might include things like aerial imagery, streets, parcels, political boundaries. Those kinds of things are typically going to be in there as 2D layers. Then you're going to have your 3D layers, which are those layers that you extract or automatically display in with that Z axis. So you have the X and the Y, but this is adding the Z to it. So any layer can be made 3D. Even though it wasn't captured in 3D, you can visualize it in 3D. And I'll show you how to do that in just a moment. But this really gives you a new way to look at your data that you've not been able to do in the past. It can really highlight the results of your analysis, information that you're trying to bring to the forefront, the story you're trying to tell, because let's face it, when we're creating a map, we're trying to tell a story, right? So let's jump into Pro and kind of take a look at some scenes and how we might use this in some kind of real world type situations. So let's go jump into ArcPro now. Okay, so now we're here in ArcGIS Pro. I have a scene open, and when I first started using Pro back in 2015, even when it was still in beta before it was released, when I started thinking about scenes and visualizing data in 3D, I immediately jumped into infrastructure. That's partially because I started out in surveying, land surveying. I've worked with engineers, civil engineers, structural engineers throughout a large part of my career. So that's where my mind went to immediately. And absolutely, you can do this in Pro, as you see here. I've got, what some might call a digital twin of a city area. So you can see I've got the buildings in here with a very realistic, looking facades on there. But I've got other things. As I start to zoom in here, pan around, you can see I've got light poles here. I've got a fire hydrant here. I've got a bush over here. And if we kind of come back here, you can see trees and whatnot. So yes, you can absolutely use ArcGIS Pro to visualize these kind of streetscapes, digital twins, whatever you want to call them, in your GIS, right? And we'll talk a little bit more about this in general. But we're not limited to this type of infrastructure for scenes. We can visualize, as I was saying earlier, any type of data in 3D. So we've got a good example of that. We're going to go to this next scene, which shows the number of GIS certified professionals, or GISPs, across the continental United States. This was at least as of a few months ago when I downloaded this data. But you can see in this scene that I'm extruding or making the states have a height to them on the z-axis based on the number of GISPs they have. And this really helps to highlight those states that have more GISPs than others, or those that have a lower number of GISPs than others. So you can see very easily that North Carolina, Virginia, Florida, Texas, and California lead the pack, as it were, in the number of GIS certified professionals that reside in those states. My state of Georgia is kind of middle of the road with 189, Colorado and Washington, Ohio and Pennsylvania kind of in the same grouping, and then kind of goes down from there. But this really helps highlight that piece of information, that number of GISPs, so that there's no doubt which ones have the most, which states have the most GISPs. And I've combined this with more traditional symbology, in this case graduated symbols. So I'm using the colors as well as the extrusion to help highlight this information, right? So I'm combining traditional 2D techniques, cartographic techniques, with this 3D extrusion to really make a map that is very visually stimulating, that really leaves no room to interpretation as to what it's trying to say. I think it's very clear what is going on. And of course I also have the label. So another traditional cartographic technique that I'm embedding into this. So using all of the tools available that I have in ArcGIS Pro from a 2D perspective and a 3D perspective is really helping to highlight this story about the number of GISPs. Here's another example. I'm going to go to this scene that I created. In this case, I'm trying to show the amount of change in value from one year to the next of these parcels, these pieces of property within a county here. And this is some very old data, by the way, so don't, this happens to be Upson County, Georgia, which is south of Atlanta. And again, this was from many, many years ago, so don't go calling Upson County and giving them a hard time. But you can see very quickly here where those changes have occurred, be it positive or negative. And again, I'm using a combination of traditional symbology, again, graduated colors in this case, and the extrusion to really make that case stand out. So I can really pick out those outliers, right, where the most change happened to occur. So I've got the ones that are negative change, the most negative change in the blue colors. So you can see that here and here. And those with the most positive change in value are orange and kind of pink. So you see that here and then here right? So you can really start to tell where the greatest amounts of change occurred. Again, this just adds another level of impact to this. It really makes those stand out a lot more than a normal 2D map would. Right? So it just, and again, just gives you another tool in your toolbox, as it were. And remember, again, this works at all licensing levels of ArcGIS Pro. And I happen to be using, I actually just downloaded the update for 3.6, I think. So, am I right? Yes, 3.6 this morning. So, that's the version I'm running. You don't have to be. This works at all versions. So you don't need to worry about that. Now that you can see the uses of a scene, whether it's looking at things like the change in parcel values or creating the digital twin, how do you go about creating one? You know, and that's really a great question and what the core of this video is supposed to be about. So let's go into the process and explore how we can go about creating a scene in ArcGIS Pro. As with many things in ArcGIS Pro, there's more than one way to create a scene, right? There's a couple of different ways to make this happen, and I'll show you a few of those, or at least a couple of those, I should say. For example, I can go over here into the catalog pane, and where it says maps, if I right-click here, you see I have the options for a new global scene or a new local scene. So this is one. I pick the one I want to create, and it would open the scene or a blank scene for me to begin building. Another way is to go up here to the tab, the Insert tab, and go to New Map, click this drop down, and again, there's the global scene and local scene. So what's the difference between a global scene or a local scene? That's another good question. Well, let me rephrase this. In most cases, I think the large majority of you watching this video would probably do fine with a local scene. A local scene typically uses a projected coordinate system like UTM, or if you're here in the United States, your local state plane coordinate system. And as a result, it's also going to use traditional planar units, so feet, meters, miles, kilometers, and so on. Right? So again, those typical types of units that we are accustomed to operating in most cases. And so, like I said, if you're working inside of a city, a county, even an area that includes several contiguous or adjacent counties, a local scene is going to be fine. You would want to use a global scene in any area where the curvature of the Earth is going to kind of impact how you visualize or display that data. So when you start to hit the state or province level, or multiple states, or a country, or a hemisphere, or larger, right? In that situation, the area you're dealing with, the curvature of the Earth in a 3D environment, is going to impact how that data gets displayed. In that situation, a global scene would be your best choice. Now, typically, did I already mention it? Anyway, a global scene uses a geographic coordinate system. So your latitude and longitude, your units are going to be degrees, minutes, seconds, decimal degrees, those kind of things. So not as easy for doing measurements and things like that. But again, visualizing that larger area where curvature can impact it is when you want to use the global scene. But like I said, I think most of us are going to be fine with the local scene, and that's what we're going to create next. So to do that, I'm going to click on the local scene option here. And so we've now created this new local scene, an empty local scene with the exception of the base map, in ArcGIS Pro. And you'll see when it did this, it generated some group layers automatically. So I have a 3D layers, a 2D layers, and elevation surfaces. Any scene that you create has got to have a designated ground surface to use as kind of its starting point for building all the other 3D data off of. Now, by default, It uses Esri's World Elevation 3D/Terrain 3D surface that comes out of ArcGIS Online. This is free to use. There's no credit usage for utilizing this as your ground elevation surface. Can you bring in your own? Yes. If you have your own DEM or TIN or terrain that you want to bring in and use as the ground elevation starting point, as it were, for your scene, absolutely. You can actually have more than one ground elevation, so that if you have a DEM of your city, but you have data that you want to display that extends out beyond that, you can use your city DEM, and then once you get beyond the extents of that DEM, it can pick up and start using, in this case, say the World Elevation 3D, Terrain 3D surface that's coming from Esri. So you can have more than one ground elevation source. It's just going to use whichever one is kind of on top, and just like we stack layers up, in draw order, the same thing is true with these elevation surfaces that we're using for the ground. We're going to have 2D layers. So you can see I already have one. This is coming from the base map, the community, and then I have 3D layers up here. So what I'm going to do, now that I have the scene created, I'm going to go ahead and bring in some different feature classes as layers so you can kind of see those. So go over here to my catalog pane. Under databases, I'm going to expand this Tripville GIS geodatabase. So this is what I use. This is in all my books with the exercises and training classes I do. So this is, if you've taken any of those or read my books, you can see that. So I'm going to bring in some layers in here. So I'll say I'll bring in census block groups. I'll bring that in for the city of Tripville. It kind of bounces me over to this new extents because I'm in Georgia now with this data. Maybe I'll bring in things like, what else do I want to bring in? My city limits. So I'm going to bring the city limits in here. You can see that. And you can see it's adding these in as 2D layers because these are 2D layers. Now I want to bring in a different layer, buildings_MP, and drop that in. So it added that in as a 3D layer up here. So why did it add this one in as a 3D layer and these in as 2D layers? So if I go back over here and look at the properties of this feature class that I added, and I go under source and I go down here to feature, or I'm sorry, geometry type, you'll see this says multi-patch. Multi-patch is a 3D data format. It basically creates a 3D solid, for lack of a better term, and for ease of understanding here. So it's drawing things in X, Y, and Z. Okay? These other feature classes that I brought in, for example, the city limits, if I open those up, you'll see that the geometry type is a simple polygon and it has no Z values. Right? So it is not 3D enabled. So that's why it made that a 2D. So any feature class or data type that is Z enabled, like multi-patch, it's going to automatically bring it in as a 3D layer. If it's not, it's going to bring it in as a 2D layer, as you've seen. So let's go ahead and zoom in on this 3D layer that we added of the buildings. We'll zoom to that layer. So you can see it here. If we start to zoom in, you can start to see those up in 3D. Now, one of the things I'm going to do is use this little navigation tool down here in the bottom. So if I grab this kind of middle ring here and drag it around, it'll rotate those out. I'm going to zoom out a little bit more because I was zooming in too far. But what you'll notice here is that these buildings are kind of floating up here in space. They're not down here on the ground. So one of the things when you're working in 3D data that you need to be aware of that's just like your 2D data is that your units and coordinate systems, datums, are all going to impact where the data displays. And in this case, this multi-patch layer was built on using a different elevation footprint, ground surface, than the Esri one. So because of that, it's just kind of floating up here in Never Never Land. Now, in this case, it's very easy to fix because I'm really trying to just display the data. I'm not doing analysis on the data or anything of that nature, so it doesn't necessarily impact whether it's correct or not as far as the z-coordinate. So if I right-click on that layer in the contents pane and go to properties, if I go down here to elevation, you'll see here that it's using the z values, right? If I go up here where it says features are, and I change that to on the ground, I go okay to that. Now they're on the ground where they're supposed to be. They're not floating up in space. That's a fairly easy fix. In this situation, the z elevations being exact don't matter for my use case. If I was doing some sort of 3D analysis or trying to look at comparisons of data in 3D with some level of accuracy because I collected it with GPS or something like that, then I wouldn't want to use that. But for the sake of creating this very simple visualization, this is a fine solution for in this case. Okay, so that's a 3D layer, makes sense. But I also said that any layer can be made a 3D layer. So I'm going to turn off the buildings for now, and I'm going to take this census block groups, because what I want to do is extrude them based off of their population density. So I'm going to bring them up here. So I just drag them up as a 3D layer, right? And we've already verified, that was a 2D layer, right? So I want to extrude this up, as I said, based on population density. And if I open my attribute table for that feature class, you'll see that I have a field in here called pop15 underscore SQMI for square miles. So that's the population from 2015 based on population per square mile. Okay, so I have that in here. So I already have a field that has that density. So that makes life really easy. So I'm going to close the table down. Now with that layer selected here in the contents pane, I go up to the feature layer tab in the ribbon, and you'll see this extrusion group. So my first thing to do is select the type of extrusion I want to do. And I'm not going to go into all the differences here. If you would like to see that explained in a more detailed video, leave a comment below and I can try to get that on the list, but I'm just going to pick minimum height here. Next, I'm going to choose the field that I'm extruding these by. So hit the drop down and I click that field. And now you can see how it's extruded that up. As I zoom out a little more, as it builds cache, I'm going to keep zooming out so you can see those in here, right? We're in the US, so I'm going to change this from meters to US feet. And now we can see the population density extrusion, right? So the higher census blocks, or census block groups, I should say, have the greater population density, right? So that's how you quickly extrude these up to do that. But as I mentioned, I can combine this with more traditional symbology that we use in our normal maps. Right, so if I want to do that, again, making sure that this layer is selected in the contents pane, I go back to the feature layer tab and under symbology, and I'm going to choose graduated colors. That opens the symbology pane over here. I'm going to select the same field I used for the extrusion, so I'm comparing apples to apples. Doesn't mean you have to do that, but in this case, I'm trying to make sure that I've got the right values in there. I can pick whatever color ramps I want to go. I'll keep the one that's here. And again, then I can rotate this down and around to better see that. Okay. So now that's really starting to pop. I can tell the values, match them up to my legend over here. Let's go ahead and close that pane and let's minimize or shrink that up so I got a little more room. And then I could further go in and back to the ribbon, go up to labeling, turn on labeling for this layer, and again pick the same field so that now I've got that value, that population density label in there. So again, I'm just combining traditional cartographic techniques that we have in our normal maps, those 2D maps that we create, with this new capability of the 3D extrusion to help highlight parts of my data. It really makes these areas that have greater density stand out compared to those that have less. And, again, could I use just graduated colors in a 2D map? Absolutely. Would it convey the information? Yes. Would it have the impact that this 3D capability that Arc Pro brings to the table now have? I don't think so. I really think this brings a whole new level of how you can display your data to tell your story, even more so than those traditional techniques, right? It opens up a whole new level of capability, in my personal opinion. You may not agree, that's fine. But like I said, it gives you more options. It gives you another tool in your toolbox, if nothing else, right? So there you have it. That's the very basics of creating a scene in ArcGIS Pro. As you've seen, we can go as complex or as simple. This is very simple. We could go to much more complex visualizations like we had here with this digital twin, where we're utilizing a bunch of techniques. We have rules-based symbology coming from CityWorks in here for the buildings, which is generating these facades around the buildings. We're using 3D styles or symbols in here for things like the light poles here and the fire hydrants and the bushes, right? We're also combining that with other things, as I zoom back out, with the views in here to set things like weather. That's where these clouds are coming from, right? So I can set cloud cover, wind speed, whether it's snowing or raining in here. So you can get very fancy or complex with this as you desire, as you see fit here. We had this other very simple one that I just extruded the states by GISP, very similar to that scene that we just created here. We can use something in between. So for this, with the parcels, the change in value, I had a challenge in that I had negative values and I had positive values here. So, in some cases, the parcel from one year to the next lost value, so that was a negative change. Other cases, it increased in value. Now, I wanted to extrude these all up because in these scenes you can also go down. You can extrude negatively, so it goes below the ground surface. But I wanted, for the sake of simplicity and the ease of viewing this, I wanted everything to go up, right, which required positive values. So I had to write an arcade expression to make that happen. So let's look at that really quick, just so you can see it. So again, go back to feature layer, and here's my extrusion group. I click the expression button over here, where it's next to field where it says custom. Expand this out, and you can see the expression in here. So what I did is I created a variable called CHG POS for change positive equals the absolute, so that's this function here, this absolute ABS that you see here, that's absolute value for the value found in this table and this field, oops, here, right? So it's taking this value, right, and basically taking the negative off of it if it has one. So just returning the absolute value, which is the positive value. And then I've got if and else statements down here. So if, right, the value in this field, the val change field, is less than 0, meaning it's negative, return, for the sake of extrusion, the variable, right, the absolute value here. So the change POS, you can see there's the variable name, there's the variable. So it's going to extrude in a positive direction, even if it's negative in the table. Else, meaning if it doesn't do this, return just that value that's in the table, which would be positive, and extrude by that amount. So again, just using a fairly simple arcade expression to calculate the amount of extrusion for each parcel. So again, not overly complicated, but a little bit more complicated than what we did in the sample there. So now you know how to create a scene in ArcGIS Pro. I really hope you found this video helpful. If you did, please make sure to give it a like, the thumbs up down below the video there. But this really just begins to scratch the surface of all the things you can do to create a scene within ArcGIS Pro. You saw some of the more complicated examples of that. So if you would like to learn more about how to create a scene, how to work with those 3D styles for things like the light poles and the fire hydrants, or how to assign and use your own surface as the ground layer, or anything like that, make sure to tell us down in the comments below. Or if there's some other topic with ArcGIS Pro or another Esri product that you'd be interested in learning about, again, drop us that comment. We'd be happy to see those and start to put together a list of additional videos that we could publish here on our channel. Also, please don't forget to subscribe and hit the notification bell so that you know when we put new videos up here, so you can see all the new things that we're trying to show and help grow your skill set in ArcGIS or GIS in general, or asset management, or any of the things that we will be putting content up on. So with that, guys, thank you so much for watching this video and supporting our channel. We really do appreciate it. And again, if you haven't done so, make sure to subscribe. And with that, guys, we'll see you in the next video. Thanks.